All right, so the Module 1 Lesson 6 problem set is essentially asking you to do a little mini version of the poster project sort of thing that we did in class today. In class today, remember you made a big poster with your group where you had this like situation with all these ratios on it. And in the first box, you were supposed to just copy your problem down. And in the second box over here, you're supposed to make a table out of the given information. Over here, you were supposed to make a graph out of the given information. And then here, you were supposed to make a conclusion as to whether or not your scenario was proportional in two ways. You were supposed to make a conclusion based on the information in your table, and you were supposed to make a similar conclusion based on your information in the graph. So here's your situation here. It's about Sally and how much money is in her account after a certain number of years. You could, if you wanted to, copy this problem right here into the problem box. But honestly, I feel like that's kind of a nonsense task for you to have to do. Oh, I just realized you can't really see the words. So if you want to just do something like I've just done, just kind of draw an arrow from the problem into the problem box, I am okay with that. So let's start making a table here. How many ratios did they give us for the problem here? It says after 1 year, the interest accumulated and the total in Sally's account was 312. So we're supposed to be writing these ratios in years to amount of money. So that means that the year number should be first and the amount of money should be second. So this ratio would be 1 for 1 year to 312. And since the 1 is first, that we're going to treat that as our x value and the 312 is our y value. Okay, so I'll start putting these in the table rather than writing them up here. It looks like they've only given us 3 ratios to work with, so we only have to make a table that's big enough to hold 3 values vertically up and down, and to put 2 values horizontally side by side. So it doesn't have to be too big. I think something that'd be really nice for you to focus on while you're doing something like this is how neat you can make it. Can you take your time to make it not look too terrible? I mean, I'm not the best either, but yeah. I feel like my boxes didn't turn out very even, but that's okay. So I'm gonna just label the top one here as years. And this one here can be money. And then I already got that first ratio figured out. That was 1 to 312. And the second one, it says after 3 years, okay, 3, the total was 340. So this already feels like it's not going to be proportional, right? Like if I'm thinking about what times, if these are my x values and these are my y values, if I'm thinking of a number that I'm supposed to go 1 times blank equals 312, well, that's 312. 3 times 312 is not 340. So hopefully you're getting good enough at these to where you can see that as quickly as I can, that this is not going to be proportional. So I got this last piece of data here. After 9 years, the total was $430. Oh wait, I'm just now seeing that, oh no, there's lots more data here. After 6 years, the total was 380. Oh geez, I didn't read this all correctly at all. So, well, it looks like I only missed 2 pieces of data, right? The 6 comma 380, the 6 years, $380, and the 12 years, 480. We can tack that on. The 6 is going to be out of order. It's going to be below the 9 instead of the 12, instead of above it, but that is not the biggest deal. We are okay. So let's go 6 years, 380, and 12 years, 480. And so the way you're supposed to make your conclusion from the table is to add that extra column like we've been doing in class. Call it your y divided by x column. And then show me all these y divided by x ratios. So that's one, and then when you go to make your conclusion in this box, that's one of the things you need to talk about. You need to talk about how you can tell this is or isn't proportional based on these numbers you see in the third column here. And then for the graph, I think just like you want to make this table as neat as possible, I think you should take the time take a little pride in your work and see if you can make this graph look pretty decent. It doesn't have to be perfect. I'm just gonna make a 1 quadrant graph. That means I'm not gonna like put 0, 0, the origin right here in the middle of the box so that I have all 4 quadrants of the graph. I'm not gonna need the negative x or the negative y values. There's no negative values in this problem, so I'd rather just have, you know, my positive x values and my positive y values. Here will be the origin 0, 0 will be right there. And then I look at what values I need to have on my x-axis here. It looks like I need to go to 12. So maybe I could do something like this. It looks like it'd be pretty easy for me to put about 6 lines here. So maybe count by 2s. 2, 4, 6, 8, 10, 12. Okay, 2, 4, 6, 8, 10, 12. Anytime you're making a graph like this, especially like on your own space, and there's no graph paper to work with, and it's not already labeled and scaled out for you, you got to think ahead about like what numbers you need on the space that you're given, and you know how you're going to fit things so you don't run out of space or it doesn't look too sloppy. So I'm looking at my y values now and thinking about my y-axis, and I see that the lowest value I need to get on here is 312, and the highest value I need to get on here is 480. And that's a spread of about 168, but let's just call it 180 to make the math really easy. Well, 180 divided by 20 is 9. So if I were to, let's say, start at 300 and then make every line worth 20, then I would only have to make 9 lines. And I feel like I can fit 9 lines on here. So that's what I'm going to do. So it's going to look a little weird because this space right here is going to go from 0 to 300. See that? How just this little space from here to here represents a change in 300, but then just from here to here is going to represent 320. We normally will never do that in class. That's called uneven scaling, and it makes graphs look deceiving or incorrect. And so we're going to get away with it this time because we don't have a lot of space to work with. But usually we won't do that. So this is going to be really hard to make neat. I'm going to start maybe putting some numbers over here. So this one will be 360 for here. And this one will be 380 for here. And this one will be 400, maybe to the right there. I was trying to get to 480. I think I'm just barely going to have the room I need. 420, 440, 460, and 480. All right, and then we just do our best to graph those points as neatly as we can and accurately as we can. So let's see here, 1, 312 should be as close to a little bit over the middle between 300 and 320 as we can, so right about there. And then 3, 340, so 3, 340. It's this line right here was my 340 line. Okay, and then I'll go to 6, 380. Right about there. And then I'm supposed to go to 9, 430. 9, 430. And then 12, 480. It looks like it's going to be pretty straight. I wonder if that'll match. Well, let's see. Here you're going up 2 years for an increase of $28. Here you're going up 3 years for an increase of 40. Yeah, it makes sense that this line is pretty straight. I mean, I guess it's maybe a little crooked, but I don't know if it's crooked because the values make it be crooked or because my graphing wasn't 100% accurate. But that's okay, Because we don't necessarily need to judge by whether or not it's straight or crooked. We can judge by the fact that it definitely doesn't touch the origin. So, and even if it did touch the origin, then it would be super crooked, right? Like it would have to go from this point and hook down. So you should be able to make two good conclusions in this box about what you got from this table and what you got from this graph. And then that's it.